All right, welcome back to geometry. It's a Friday morning. We are scoring lessons 78 and 79. I know you all had questions. I got the questions. I did not get them all answered individually, but I have them notated here, and we'll hopefully address them as we go here this morning. Lesson 78. First one is number 1. We're on page 513 in the textbook, and you should have your answers in front of you as well. Lesson 78, problem number 1. Write an equation for circle A. Circle A is graphed there. It is centered at the origin. So again, you're going to use the simple formula of a circle. X squared plus y squared equals the radius squared. What is the radius? Count. 1, 2, 3, 4, 5, 6, 7. If you notice the numbers, it is 7. The radius is 7, so 7 squared means your answer should say x squared plus y squared equals 49. That is the answer for number 1. Number 5, which of these diagrams could not be the net of a triangular pyramid? Remember this from one of our earlier classes. Here's a triangular pyramid. It might be hard to visualize without this, but you should be able to in your head anyway. A is going to work very well, folds up. B and C are equivalent to each other. They work. D will not work. So the correct answer for 5, which one could not form the net, is letter D. Now letter D looks like our famous baby carriage kind of turned sideways. So if you use that figure, you would actually come up with like the top half of this. So I don't know if you can see it, but it would form this thing. It would come around and be an open cup if you cut part of this off. So D does not work for the question they're asking for number 5. All right, number 6. Triangle FGH has vertices as listed. You're supposed to graph it and then graph the original and then graph its image after a rotation of 270 degrees counterclockwise about the origin. List the coordinates of the vertices. So you should have a graph. You should graph the original original triangle, which is the pre-image, and then rotate it 260 degrees about the origin and graph it and list the coordinates. Here are the coordinates, and then I'll show you the picture. The coordinates of the new triangle, which is actually the image. And it is f prime, g prime, and h prime. So f prime is 5, negative 4. G prime is 2 and negative 1. H prime is 1 and negative 5. If you flip back to the beginning of that lesson, it talked about a rotation of 260 about the origin, and then it gave the mapping notation for that, and it said that x and y became y and negative x, I think. Is that right? Which makes sense if you look at the original list and the new list. So the original F was 4 and 5. This is listed from your book. 4 and 5. G is 2 and 1, and H is 5 and 1. And compare those to the new answers that I just gave. You simply move the y shifts over and becomes the new, so the y becomes the old y becomes the new x. So this is 5, and you can do this quickly. This is 1, and this is 1. Is that what I said? No, I have these switched. So this needs to be switched. That's why it didn't make sense, and you all probably saw that. This is 2. And then the y becomes the x negatified. If there's such a thing, negative 1 and negative 5. This is for f prime, g prime, and h prime. And I hope we did that right. You'll notice that they follow this formula, kind of. It's not asking for this formula, so that's fine. You don't have to have this formula in there. I'm just saying that that makes sense if you refer to it back there. You are supposed to have this listed, and you are also supposed to graph it, which looks like this one where my finger is, right there. And now you're going to madly pause the video and copy all those answers down. That's okay. It's not okay, but anyway. All right, let's keep going. Number 11. Same idea. This is triangle ABC. It has vertices as listed. Graph it after 90 degrees counterclockwise about the origin and list the coordinates of the vertices. So the new ones are A prime is negative 4 and negative 2. B prime is negative 6 and 3. C prime is negative 3 and 1. And again, you could verify that with the new 90-degree one becomes x and y becomes negative y and x, I think it is. Negative y and x. So again, the positions change, and this time the y number gets negatified, oppositified. I'm going to create a new word. Negatified. Negated, I think, is one way to say it. 11, 13. There was questions on 13. A special cone has a property that has a radius. The radius is the same length as its height. Determine a formula for the volume of such a cone in terms of the radius r. It just means it wants a formula, but it wants an expression with radius, in terms of radius, like everything about it is radius. Well, the original formula for the volume of a cone is 1/3 of base times height. The volume of a cone is 1/3 of base times its height. Now, what is actually another formula to find the volume of the base, to find the area of the base? Well, the area of the base is pi times radius squared because it's a cone, and so the bottom is a circle. I still have a cone here, don't I? So here's the cone. What's the expression for base? It's a big B. It means the area of the base. Well, the area of the base is pi times radius squared. So you could substitute that in there. We're just getting rid of these other numbers and putting r in its place. And what terms of r? So for this case, it's 1/3 of pi times radius squared. And then it also said that its height, right here, is equal to its radius. So you can substitute the h, minus the h, and put another r in there. The volume of this new cone is, or this special cone, is 1/3 of pi times radius squared times radius. Well, radius squared times radius can be simplified further. The volume of this cone is 1/3 pi times radius cubed. That's actually the answer on the score key. Now, it may be kind of hard to know that's what they were looking for, but it said in terms of its radius, so it's asking for, in essence, it's asking for all the variables to be in terms of radius. I mean, pi, we have to have that, we have to have 1/3, but all these other things, can we substitute them all for radius, and what does it look like? Radius cubed is how that should look. 19. Riss is making a cone, including the base, out of paper. She wants the height of the cone to be 12 centimeters and the radius of the cone to be 5. How much paper will she need? So you're looking for the surface area of this cone. Use the correct formula, and you would get approximately 282.7 square centimeters. 21 is another triangle. We're wearing this out. 21 is a triangle RST, and this time it's just saying graph it and its image after a rotation of 90. So it's not actually asking for the coordinates. I mean, it tells you what the original are. It's not asking for the new ones. But again, it's 90 degrees about the origin. So it starts here and goes this way, counterclockwise. And it looks like this one. So there's no, this top one up here, there's no coordinates listed for either one on here. You have the coordinates of the original listed in your book, and you can figure out the other ones. That's what it should look like for 21. 24. A mason is laying bricks for a fountain. The water is to pour out of a semicircular gap in the structure. With a 3-foot diameter, there will be a brick trapezoid patio around the fountain as shown. If each brick covers 24 square inches, estimate the number of bricks needed to build the patio and fountain. So, do the math, subtract some out of there, and you get, so you're looking for the area of a trapezoid. It's 1/2 base 1 plus base 2 times the height. You find that, and then you're going to have to substitute out, no, maybe not. Anyway, 540 bricks, approximately 540 bricks is what you're looking for. That is after you take the area and convert it from square feet into inches, because the bricks cover square inches and you're figuring it in terms of feet. How many square inches in a square foot? The answer is not 12, the answer is 144, so that should determine, that might trip some people up. 144 square inches in a square foot. Do the math, you'll get 540 bricks approximately. All right, let's keep going. 24. That is it. So 79, lesson 79, number 1. Number 1, lesson 79, which of the following is true for angle x? The answer is C. The measure of angle x is greater than the measure of the arc VZ. So C is the correct answer for number 1 on 79. Number 3 of 79, sketch the image of the figure after a rotation of 270 degrees counterclockwise about the origin. 270 degrees, that's a pentagon looking shape. It is sort of centered up here, but it's actually a little higher, so it's going to rotate. You're going to rotate it this way. You can't really see what I'm doing. It's here, you're going to rotate it. There's 90, there's 180, and then it comes over here at 270. So roughly the original one looked like this, something like that. You're going to rotate it around, and now it will look like this, and you can't read it because it got all scribbled. But it's tilting on its side. Let me show you a better picture of it here. And is it asking for the coordinates? It doesn't say to give the coordinates, but they are listed there. There is the pentagon. It had been up here, and then it got rotated like this, 90, and like this, 180, and came around like so. And then there's your new coordinates. Hope that makes sense. Number 8. What is the measure of angle BAC? The measure is 80. The measure of angle BAC is 80 because you take 260 minus 100 off of that, you get 160, and you find half of that, and it is 180. Remember, it's the difference, it's half of the difference of the two angles. 80 degrees for number 8. 12. Multiple choice, which of these could be the graph of cosine of x? Again, it's coming back to this chart that we had, and we know that the graph, if you look back or you look at your paper that you made, is between 1 and 0, and it starts at 0, so it's not A, because A shows the curve and it actually goes back up again, it stops, and it's not C, because C goes up and then curves around. And the cosine of a 0 degree is 1, so it's either going to be B or D. It goes from 1, angle of 0 is 1, angle of 90 is 0, and then in between. Now you could say B, but it's actually D because it's not a straight curve. Not a straight line, it's curved. The answer is D. If you put B, that's okay for today. We're going to leave it at that. So I would say either B or D is the correct answer for 12. Technically, it's letter D. Number 17. Triangle DEF has the vertices as listed. Graph it and rotate it 180 degrees counterclockwise. So we should know how to do this by now. And list the vertices of the image D prime, E prime, and F prime, the triangle there. So you should graph it, and you should have the list of the vertices. The list of the vertices, the new ones are going to be D prime is -3 and 3. E is 0 and 1. And F is 2 and 4. If you remember, again, you could go back to the beginning of lesson 77, and if a point xy is rotated 180 degrees about the origin, then x and y becomes negative x and negative y. It's just, everything is, here's my word again, everything is negapied. The graph looks like this, right there. Alright, we certainly are getting practice rotating figures. Number 17 we did. 21, find the measure of Q. You're going to have to do some work here. You're going to have to find what that unnamed, unmarked arc is, and then subtract that from 66. The answer that you should get is 70 total. The answer for 21 is 70 degrees. 22, line segment AB has points as listed. Graph the line segment and then rotate it 180 degrees and list the coordinates of the new one. The new one should be graphed at A prime is going to be 4 and 2, B prime is 1 and -5. Again, it's the same thing as our 17. We're taking the same x and y and just making them opposite. And the graph is just going to be two lines, and they look sort of similar. They're parallel because they went 180 degrees rotated about the origin. 22, 27. Find the measure of angle 1 in the figure below. Rays that appear to be tangent are tangent. And the measure of angle 1 is 10 because 90 minus 70 is 20, half of 20 is 10. And number 29, a piece of raw peridot. Now, my first question is, what's peridot? It's actually a gemstone. If you look it up, it's a gemstone. It is cut into a rectangular prism, then a triangular face is cut at each vertex. Find the number of faces, edges, and vertices after all 8 vertices of the prism have been replaced by triangular faces. Now, what does that mean? It helps if you have something to look at. This is a square or a cube, but it works as a rectangular pyramid. It has the same number of faces and sides and all that. So, what it's saying is it took this rectangular pyramid and it cut every corner into a triangle. So it's just cutting these sharp corners off, all 8 of them, and replacing them with, it'll be like a triangular face is what it would look like right here, because that triangle, I'm not going to do it to this one, but this point got cut off and you're left with, you just have to imagine in your head, you're left with a triangle shape right there. So the question is, find the number of faces, edges, and vertices, and then check it with Euler's formula. Now, so, which he had a birthday here recently, right? According to Savannah. Susanna, I mean Savannah. Said it right the first time. How many vertices are on this thing to begin with? 1, 2, 3, 4, 5, 6, 7, 8. Let's start with vertices. So there's 8 vertices to begin with. Where's my eraser? 8 vertices. How many faces? 1, 2, 3, 4, 5, 6. 6 faces. And how many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Now, let's figure it out after this. Let's go with the faces first. So we had 6. 1, 2, 3, 4, 5, 6. And we still have those same 6. They didn't disappear. So we have 6 plus we've got some more now. And how many more do we have after we cut this at a triangle? It creates a face here. So every vertex gets a new face. We've got 1, 2, 3, 4, 5, 6, 7, 8. 8 new faces. So 8 plus 6 should be 14. We now have 14 faces. And vertices, we had 1, 2, 3, 4, 5, 6, 7, 8. And what happened? Well, the ones that we had disappeared because we cut them off. The original 8, that point left, that's trash. And what took its place was 3 more. If you remember this or envision this triangle in here, there's going to be one on this edge, there's going to be one here and one here, and I could actually draw it maybe. Yeah, if we cut it off, it would look like that. That is gone, and there's a flat face, and now we've got 1, 2, 3. So what had been 8 now is 3 times 8, because we've got 3 here, 3 here, 3 here, 3 here, and so on. So we have 24. This is the long version of the answer, but 24 vertices. And then edges, how many edges? Well, we're going to keep the original 12 that we had to begin with, and we're going to add 1, 2, 3 more at each place. So we're going to add 24 more. We've got 8. We've got 3 here, 3 here, 3 here, and 3 here. 3, 6, 9, 12, 3, 6, 9, 12. So we're adding 24 more edges to this original right here, which means 36. Now the question is, does that satisfy the formula? Faces minus edges plus vertices. 14 minus 36 plus 24, and it does equal 2. You can check it with your calculator, which you should have already done. All right. I don't think I talked about the test, so I should have done that at the beginning. We'll do it at the end now. So we're done scoring lesson 78, 79. You're next going to look at lesson 80 and investigation 8. And that is going to be due Monday. The tests, they got kind of lost in the shuffle. They are coming to you on Wednesday, I guess, for when you pick up. You're going to pick up Tuesday morning, I think. They'll be in there. You'll look at them Wednesday morning. I'd like you to get them out and have them in front of you, and we'll go over a test review for the old test. So in the meantime, someone was asking about how many tests we have left to go. We are ready for a test here soon, or we're at a time for a test. I don't know if we're ready or not. Hopefully we are. We will be soon. Lesson 80, investigation 8. You're going to do that work today. It's going to be ready for Monday. Monday morning, we're going to score lesson 80, investigation 8. And that's probably all we'll do. Wednesday, we'll look at our old test, the test you took already and are just now getting back. We'll look at that, talk about that, and we'll also do a test review for the new test, and maybe do the test on Friday. So all that to say, the new test coming on Friday. We have a long time to study for that. It's a week away. I'll give you the test review on Wednesday. You can study it Thursday and take it Friday. And then the fun begins. I need to talk to Mr. Troy about the schedule. We are winding down. I really wish we'd be together. We're not. We may, hopefully, I hope, that we'll have one more test after this one we're just getting ready to take. So 2 more tests total. The last test will be at the very end, and it will not be a whole course test, but we're going to, probably here soon, we're going to start skipping lessons. So once we start skipping lessons and picking the interesting ones, which is what I want to do for a long time, once we do that, we'll have to pick and choose and kind of come up with a test. But I'll do that in the future. So I hope that answers your questions. Again, you finish scoring. Tell me how many wrong you got. And I know it's kind of vague. Well, do I count this wrong and that wrong? Just Courtney was asking about, if they're in terms of pi or rounding or whatever. Just as long as we understand when they asked for the answer, just give it in the answer that they asked for. You don't necessarily have to count it wrong if you can convert it. Like say you gave it in terms of pi or you gave it in simplified radical form, but it actually simplifies to the answer that I said, then that's fine. It is practice. It is life practice of doing something exact. So there are some people that on this last test who did not do them in simplified radical form or did not round or whatever, and I try to say, do what the test says. And that is still the case. Do what the test says. It's more important to me on the test, and it is just practice for life. If something is exact and says to do this a certain way, then that's the way we do it. Anyway, that's my little pep talk. You didn't ask for that, but that's all right. We're going to stop there. Thanks.